Hey guys, Mr. Middleton here. Today we're going to look at graphing systems of equations. At the end of this video, you should be able to explain what a solution looks like for a system of equations, and you should be able to solve a system of equations by graphing. Okay, a system of linear equations, and I'll usually just call it a system, is two or more linear equations together. Okay, and the solution to a system is any ordered pair that makes all equations true. Okay, so let's look at a couple examples here. It says, is 3, -4 a solution to the system? And so you can see, because remember our ordered pair is always x comma y. And so our x in this case is 3, our y is -4. As we plug this into our first equation, 3 minus 7 equals -4 works for the first one, but it needs to work for both. So now we plug our values into the second one. X is 3. Y is -4. 5 times 3 is 15. Minus 12 equals 3. Great. Works for both. The point 3, -4 is a solution because it makes both equations true. All right. Second one, it says, is -1, 2 a solution to the system? So we'll do the same thing, just making sure that we plug our values where they belong. 2 equals 4 times -1 plus 6. And that's -4 plus 6, which is 2. Works out great. Next one, 3 times -1 plus 2 equals 1. Okay, so that's -3 plus 2. And -3 plus 2 actually equals -1, not 1. So it doesn't work. The point -1, 2 is not a solution because the second equation is not true. Solving a system by graphing. So here we go. It says graph both lines on the same coordinate plane. That's basically what we're doing. That's all solving really entails, and then we'll talk about how we can find our solution. So I'll graph these in different colors just so they're a little bit easier to see. Okay, so first one we have y equals 1/2 x minus 5. This is in slope-intercept form, which is nice for us. Our intercept is -5, 1, 2, 3, 4, 5. Our slope is 1/2, goes up 1 over 2, up 1 over 2. I'll continue that through the graph, down 1 over 2, down 1 over 2. Okay, and our line would go through there somewhere. So with that, put that ruler there. So there's my line. All right. Then I'll do red. Plus 3 is our y-intercept, 1, 2, 3. -3/2. Make sure I know that I'm going to move down 3, 1, 2, 3, and over 2. Down 3, 1, 2, 3, and over 2. Down 3, 1, 2, 3, and over 2. Bring my ruler out. Away. All right, so which point is on both lines? You'll notice as we looked at our graph, as we graphed these both of these lines, that they do meet at a point, this point here. Okay, that coordinate would be 1, 2, 3, 4, 1, 2, 3. Okay, so that coordinate is at 4, -3. Okay, let's do the next problem. We have y equals -2x plus 4. So this is in slope-intercept form because y is by itself. 1, 2, 3, 4. So our y-intercept, -2 tells me to go down 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, up 2, left 1. Okay. Try to make a ruler through there. Okay, a ruler. Okay, and now our second line is not in slope-intercept form, but hey, it's in standard form, and we can actually, both numbers go in here, so I can find my intercept, right? My 3x equals 6. Find my x-intercept, and that x-intercept would be at 5 by 3, x equals 2, so at 2, 0, 1, 2, 0, 8. And then my other one at -2y equals 6 divided by -2. That gives us -3. 1, 2, 3. Okay, and so through those 2 points, I have a line. And that's standard form. All right, and so which point is on both lines? This point right here, and its coordinates will be 2, 0. Okay. So where do you find the solution to a system of equations on a graph? At the intersection of the lines. So going back here, all we had to do was graph two lines on the same coordinate plane and solve by graphing the point that both lines meet at, or the intersection point, is our solution. So for number 1, our solution is 4, -3. For number 2, our solution is 2, 0. All right, here, some special cases. It says graph both lines on the same coordinate plane. We have y equals 4x minus 3. So my y-intercept is -3, 2, 3. My slope's 4, up 4 over 1. 1, 2, 3, 4 over 1. Down 4, 1, 2, 3, 4 over 1. Okay, positive slope, great. Get my line out. All right, goes through all those. Bye-bye ruler, here's red, okay. So now, this next one, it's in standard form, so I have -8x equals 8 divided by -8, x equals -1. Okay, and then my other point, I have 2y equals 8 divided by 2y equals 4, so my y-intercept is at 1, 2, 3, 4, 0. Okay, and so my ruler goes through those two. That should work out. All right, and so hopefully you notice this, is that, hey, these lines aren't going to touch. These lines are, what point is on both lines? None. Since these lines meet never, never, we say this system has no solution. Okay. All right, next one here, we have y equals -3x plus 1. Y-intercept is 1. -3x tells me to go down 1, 2, 3 over 1. Do that a couple more times. 1, 2, 3 over 1. 1, 2, 3 over 1. All right, so line goes through there. Okay, bye-bye. All right, and so for my blue line, this is in standard form, but this is going to give me a fraction as an intercept, and so I don't want to use that. I'm going to put it in slope-intercept form. Subtract 9x from both sides. I get 3y equals -9x plus 3. Divide by 3. And I get y equals -3x plus 1. Okay, and you should notice, hey, these are the same lines. This is the same points. Everything is the same. Since these lines meet everywhere, we say that this system has infinitely many solutions. Infinitely many solutions. Okay, typically we will abbreviate this as IMS. All right, and so here, these lines meet never. I should have said nowhere because that's an actual place and not never, since that's a time. Okay, they have no solution. These lines meet everywhere, so they have infinitely many solutions since the line goes on for infinity and beyond, as Buzz would say. Here's our summary. If two lines have different slopes, that means they will intersect and have one solution. If two lines have the same slope and different y-intercepts, that means the lines are parallel and have no solutions. And if two lines have the same slope and the same y-intercept, the lines are coinciding or the same and have infinitely many solutions. Okay, so looking at this, if the question just says how many solutions do they have, we don't have to solve it all the way out. We can just say, okay, well, which of these is true? Okay, what do we know about their slopes and y-intercepts? So this first one is in slope-intercept form. We don't have to do much to it. The second one we probably want to put in slope-intercept form. So I'm going to subtract 10x from both sides, and that gives me negative 2y equals negative 10x plus 14. Divide by negative 2. We get y equals 5x minus 7. Okay, and so as we look, these are very similar equations, but they are not the same. This has a slope of 5. This has a slope of negative 5. They have different slopes, and so we know that there's one solution. Okay, and we don't know what the solution is from what we just did, but we know that there is one solution. All right, there you have it. Solving systems of equations by graphing. See ya.